We'll show you how we can use the Involute Gear package, which is part of the Mill Standard and Mill Pro products. So there's two ways to run the gear package, either from within PartMaster CAD or standalone. So I'm running it as part of PartMaster CAD, which I've started. So to use the Involute Gear module, you go to Machining, Involute, and this is the Involute Gear module, which you will find if you run it from your desktop. This is what you get. So basically it's either metric or imperial units that you're working in, and then depending on the units you need to decide which parameters you have, which will design the tooth. So for a metric thread, it's normally the module and the number of teeth, but depending on what information you're given, you'll need to specify which one of these options you need. So we'll go for module and number of teeth. So we click next. So we can set things like the pressure angle, which is pretty much standard at 20 degrees. The metric module, let's have 2.5, and let's have the number of teeth at say 20. And you can either do a spur or a rack gear. You can have an internal or an external gear, and the display can either be the tooth or the gap. So you'll see what happens with this in a moment. So if I say finish, that just designs me a single tooth, and the tooth is created such that the tip is at the outer diameter. If I'd specified gap, then the gap here would have been at this position here. So we can either have a single tooth or an entire gear, and then on the left hand side here you have the properties of the individual elements that go to make up the gear profile. So many but not all of these can be modified to increase or decrease the tooth width, and you can change things like the addendum, dedendum, add in a root fillet or a tip fillet or tip relief. So to alter any of those options, you can either click into this window here and alter the value, and that cuts down the addendum. If you want to, you can add in a root fillet, and so on and so on. What you can also do is go up to the design window here and change the values, or do things like dimension over teeth or dimension over pins, or you can set the tooth thickness, the involute tolerance, and so on. If you click reset, then things are set back to normal, but the fillet rad is kept there. If you want to take that off, you just click into here and set that to 0. So there's lots of different options that you've got there for designing the tooth. The next thing is whether you want to export that as a single tooth or as an entire gear. In most cases, if you're doing any milling or wire EDM work on this, it's perhaps easiest just to do a single tooth and then use step and repeat to give you the entire gear. But if you want to do the entire gear, you just click gear. Okay, right, so that's created the gear with the parameters that we've given it. Now we need to export that. So we go File, Export. So the options you've got are an XML file, which we can read directly into our CAD or CAM system. You can do it as a VB script. This is there so that you can edit that VB script and do some clever things with it if you feel like being a programmer and doing that, or you can output as a DXF file if you're taking it to somewhere else. So we'll use XML, and we'll just put it in a folder and give it a name. Okay, so that's exported the XML file. If you wanted to, you can save this as a gear file so that you can recall this as a separate entity outside of PartMaster CAD or CAM and use it again, or modify it as you need to. But if you don't need to do any of those things, you can exit without saving. Okay, so we're now back to the drawing, so we go File, Import that XML file we created and find the folder that it was stored in, and that was Gear 44. Okay, so we can set up an origin for that gear. So in this case I'm just going to put it straight on the drawing datum, which is in the middle of the piece of paper. Okay, so that's the gear profile that we've got there, and when that comes through into the CAD system, it's created as a contour. So if you just want to machine that, you can simply take that directly into machining. Let's save this away as a PartMaster drawing. And we take that directly into the milling or the wire EDM software, depending on how you're going to use it. Okay, so this is the basic CAM system here. We can define a tool, make this quite a small tool. Select that tool for use and then do some machining on. So we use the go round command, and we want to use that contour, probably cut to the right, and then we'll take off the approach and run off. We don't need those. Okay, so that's now going to generate the toolpath for that gear. Okay, so that's done that. If you needed to, before you go into the machining software, you could use the CAD system to modify the drawing or to dimension it and produce a detailed drawing. If you do any of those things, then what you'll find is that the profile has been created as a contour. So what we can do with that is we can explode that contour down into its basic elements. So we go to Curve, Explode. Okay, so that will convert that gear detail into individual lines and arc segments. And if we want to have a look at those, we can show the near points on that, and we can see the individual tangential arcs that go to make up that gear profile. It's important to bear in mind that that's not an approximation of an involute form, it's a real one. So if you do a query, you'll find that all of these elements here are arcs rather than line vectors. So what you'll get there is you'll get a very accurate involute form. As I say, if you need to, if you wanted to produce a drawing of that, then we could put some dimensions on it, for instance. Hold down the shift key to dimension from one point to the next. If we needed to, we could dimension the pitch circle and the base circle and so on. So you can use the CAD system to create a complete drawing of that, or you can use it as the basis for a part. For instance, you might need to remove some of these teeth if you were doing a particular type of cog design. So that's how you use Involute. Start off with the CAD, call up the Involute function, produce an XML file and import it back into the CAD, or you can use the Involute as a standalone module and export to DXF to some other software. Okay, that's it.